Hey, hey, hey. Hello, students. We're back to continue where we left off yesterday with forces and motion. And we're going to continue today by talking about the force of attraction. That's right. We're going to be talking about attractive forces today. Are any of you attracted to someone else? Perhaps someone in this room? You want to take a moment to share that with anyone? Well, let me just say that you are, in fact, all attracted to one another. In fact, you are most attracted to the one you are closest to. Now, of course, we're all 6 feet apart from one another right now, but you are all attracted to one another. What am I talking about? Well, I'm not talking about the romantic sense of attraction. I'm talking about physics here, ladies and gentlemen. We're talking about Newton's law of universal gravitation. You've heard the story before about Sir Isaac Newton sitting under an apple tree and boink, apple falls on his head and voila, he gets the idea of gravity. Now, please, please, please do not think for one moment that Isaac Newton invented gravity. He is not known for inventing gravity. He did not invent gravity. In fact, he's not even the first one to have observed the effects of gravity. That probably came about when the first person on the planet fell down. But what Newton is noted for is thinking about this invisible force of gravity and actually trying to explain it to us. So Newton is remembered for explaining gravity, not inventing gravity. So please don't make that mistake. And what Newton's law of universal gravitation states is simply this: all objects are attracted to one another by the force of gravity. All objects. So you can name any object you want in the universe, whether you're talking about something big like me or a tiny little ducky like this. All objects in the universe, by the way, I put this little ducky right next to the camera on my computer so that I look at my ducky. And when I'm looking at my happy little ducky, it brings a smile to my face. But you think I'm looking at you in the classroom and you bring me a smile on the face. Not to say that you make me frown. I'm just saying it's the little rubber ducky I'm looking at that makes me smile so much. Okay, let's move on. So all objects attract each other by the force of gravity. Gravity exists throughout the universe, and all objects are attracted to one another by this force. Well, how exactly does that work? Well, gravity is a force that works because of mass. In other words, any object that has mass is going to be attracted to other objects that have mass. So the more massive an object is, the more it's going to attract you than an object with a smaller mass. So that little rubber ducky I was telling you about there, that little rubber ducky is more attracted to me than I am attracted to the rubber ducky. Why? Because I am more massive. I have more mass than that rubber ducky does. And so the rubber ducky is attracted to me. It's the same principle that allows you to jump and fall back down to Earth. You can't jump and put yourself into orbit because the Earth is a lot more massive than you are. And so you are more attracted to the Earth then the earth is attracted to you. You can't just kick away the earth because you are drawn to it. Again, if you try and jump up, you're going to come down because the earth is so much more massive than you are. Likewise, there's something in the center of our solar system that's even more massive than the earth. Call it out if you know what it is. Yeah, it's the sun. The sun is a million times, literally, a million times more massive than planet Earth. And so the earth and everything on the earth is attracted to the sun. That's one of the things that keeps us in orbit around the sun. It's because the sun is so massive, we're just really attracted to it. We are always more attracted to things that are more massive than us. So when you think about the mouse and the elephant, who's more attracted to whom? Is the mouse more attracted to the elephant, or is the elephant attracted to the mouse? Yeah. Mouse is attracted to the elephant because it's more massive. Maybe that's why elephants run away from mice all the time. They're already together with other elephants. They don't need a mouse to be attracted to them. All right, so gravity, a force of attraction between objects with mass. Now, this brings us into a really important distinction that I told you a few weeks back we're going to get to, and I'll explain the difference. Well, today's the day. And that is the difference between weight and mass. Weight, that thing that you find when you step on a bathroom scale, is a measure of force. Weight measures the force of gravity on an object. And it is dependent upon your mass. But remember, mass doesn't change, but your weight can change from one place to another. It's true. And if you recall from a few weeks back, we might remember that we weigh more at sea level than we do up on top of a mountain. We weigh a lot less when we're far away from Earth, orbiting the planet in the International Space Station. In fact, you can be weightless and fly around, even though your mass is the same and doesn't change. So your weight, or the weight of anything for that matter, measures the force of gravity on an object. So when you step on a bathroom scale, what you're really measuring is not the mass of your body, but how much you are attracted to the earth. That's what weight is. It's a measure of how attracted you are to our mother planet. So think about that the next time you're on a scale and you see whatever number you see, just think to yourself, that's just a measure of how attracted I am to the earth. Isn't that a nice thought? Okay. Now, just like anything else in science, there is a formula or a mathematical equation. And for weight, it is this. Weight is equal to mg. What do you think the M stands for? What do you think the G stands for? Well, let's check it out. G does stand for gravity. More specifically, it's the acceleration due to gravity. In other words, if you drop an object, it's going to fall down. Why? Because of gravity. And the lab activity tomorrow is going to further explore the relationship between gravity and mass and the rate of fall of an object. We'll get to that later on. M stands for mass, and W refers to weight. So your weight is dependent upon your mass, but it's also dependent on the acceleration due to gravity. So in other words, if your mass is, say, 56 kilograms, that mass stays the same. Your mass is the same if you are here on Earth or if you take a trip to the moon. But your weight does change based on the different masses of the objects you're standing on. Isn't that cool? So your weight on Earth would be measured as 560 newtons. That is a measure of weight in the metric system. And check it out, to get from kilograms to newtons, you just multiply by 10. So 56 grams mass is the same as 560 newtons here on Earth. But if you were to take your little mass and go to the moon, your weight would only be 90 newtons, because the moon is only 1/6 the mass of planet Earth. So you weigh less on the moon than you do here on Earth. That's kind of cool when you think about it. So you can lose weight if you wanted to lose weight, become an astronaut. Go to the moon and you'll weigh less. Go to Mars and you'll weigh less. Or just go up into space and you'll weigh nothing, because the force of attraction of Earth will be so little, it'll be so negligible, you'll be able to fly around. And golly, wouldn't that be just so cool to fly around? Now, I am going to end this video now so that you can get caught up with some introductory information about tomorrow's lab activity. We're going to watch another video that will help us understand tomorrow's lab. So I'm going to call it quits here for this brief video, and you might even have some time for an activity. So for now, I'm going to say bye-bye.